This is our XRF Analyser, which stands for X-ray Fluorescence Analyzer. And this uses ionizing radiation to test material specifications, looking at the different weights and densities of individual elements. So at KMP, everyone within the Quality Department is a trained radiation protection supervisor under the Ionizing Radiation Regulations 2017. All of the equipment at KMP is calibrated regularly. So this is no exception. The XRF is no exception, and is calibrated on a yearly basis. So one of the really beneficial things about this individual analyzer is that there's a live view screen. So you can see it here on this computer. We've just reflected the screen of the analyzer onto the computer. So Harry's actually moving the cut piece of valve insert at the moment to get the optimal position. And there's also a very small film over the analyzer face, which prevents any contamination of other materials within the analyzing space and the element itself. So for smaller items, we will use this box. However, if there is a larger item, for example, a crankshaft or a camshaft, something that we can't put within the bedline box, we will make sure that we have a designated area of 3 meters where only the radiation protection supervisors are within that area.
We've had to do some destructive testing here. As you can see, the valve seat insert is now in 4 pieces because we believe there was some sort of coating on the valve seat face, such as stellite. So what we did is we snapped it in half, and now we can ensure that we get the proper material specification from this part.
So I'll now start testing the piece. The lights have come on just as a warning sign that we're now using ionizing radiation to test the material specifications. And next is now coming up on here is the different weights of element composition. In addition to that, we've just heard a click. That's when we've changed over to now look for the light elements that Harry described earlier. So we tend to test for around 20 seconds, and that should give us enough time to come up with a detailed analysis into the material. And it gives you a breakdown of each of the different elements that have been tested, the percentages that we recorded, and then the tolerancing of that as well. And we can also add information such as batches, so looking at different GRNs, whether it was an OEM or a KM products sample. And if it did match to an alloy, it will let us know what that alloy was as well.
This is the software that can't be tampered with. We can't change the results that are on this piece of paper because they're encrypted.
Within the actual XRF itself, there's a built-in library of a vast selection of global material specifications. This particular piece of equipment from Nison produces a report which cannot be tampered with. It's one of the only reports that you can take to court, and we can then use that and make comparisons to other material specifications. The library of materials that we've built up over many years, along with our knowledge as a department to ensure that the materials that we're selecting for our parts had the correct tensile strength and density to ensure that we've got the right product.